So, out here on 1959 Axeman Anderson here, we've done a lot of different things with it over the past couple of years, and unfortunately that has led to a lot of bugging wires together and hanging stuff in places where, you know, maybe it might be a little hazardous. So, for the holidays, we have planned a big rewire project. Kat's kind of concerned about the rewire project because she knows we'll have to shut the thing down for a while. And she hates it when the garage boiler's shut down. So anyway, yeah, it's still wired up. That was interesting. It just drove the stack temperature down below the set point, so it shut the auger off right after it started. Interesting. But anyway, back to rewiring. So the plan was to take our 3 controllers and 2 hour meters and wire them to 2 relays in a project box. And that's what we're in the middle of doing. Unfortunately, we've been waiting for almost 2 weeks now for the 2 relays. So we're kind of not really at a standstill. I've been downstairs working on the box and getting it all together and stuff. So what we're going to do today, I think, is we're going to temporarily pop one of these single aquastats back in here. Get our other old aquastat that we were using for an ash temperature controller. And stick those 2 things in place while we take our 3 controllers out and get them mounted in the box and wired and tested. I really want to test them separately because for right now, since it's taken so long for these relays to get here, I don't know why it takes so long. They're nothing real special, but I have some automotive relays that I might temporarily put in there just to see if they work. I mean, they're not good for the long term because who knows what the contacts are rated at. They're automotive relays, so the most they're going to see is, 14 volts DC. In a 120 volt AC system, you're going to see a lot more than 120 volts, which is way past what they're probably rated, but we'll see what happens. The fallback plan will be to use the solid state relays. Okay, so here's where we are with the project box. Got it pretty well wired together here. These are kill switches for the fan motor and auger motor. This will go directly to the fan motor, this will go directly to the auger motor. This is the main power in from our fused on-off switch mounted on the wall. And this one is the timer. And there's our 2 hour meters. The 3 controllers will go in here. And theoretically, when we get them, the relays will mount right to the front panel here, K2, and here, K1. And this is the wiring diagram. So the way this is going to work is the boiler control over here will control boiler temperature, and we have the ash temperature, ash controller, which will control the ashing temperature, and the stack temperature inhibit for ashing is over here. So the output of this will run through the output relay of this and trigger the coil side of our relay on. Same thing with the boiler side. The output of the boiler controller will trigger the K1 relay on and off. The K1 relay runs right off of a direct hot in one side to the common connection on the relay. The other side comes out to normally closed, and then that goes through actually the Honeywell high limit controller that's mounted on the front of the boiler. So that's our safety right there. And also this is where the timer comes in. The timer will connect to the same spot. So the timer can't run the boiler unless it's above the high limit on the Honeywell. And after you go through the Honeywell, then this will also power the common side of the K2 relay, which is for the ashing motor. So that way the ashing cannot occur unless the boiler is actually running the fan. And these are our switches here. One for the fan, one for the auger. And notice that after the kill switches are where our hour meters and motors are wired. So that way, if we kill it for whatever reason, the hour meter is not going to continue to run. And I have the solenoid drawn in here. Right now we're not going to use the solenoid at all, just because we're controlling the auger motor with the ash temperature. So it's just drawn in there in case you wanted to switch it back to use the solenoid. And that's pretty much it. What we're gonna do is since we're still waiting for these relays, these are the automotive relays that I had that probably won't last long if you use them with 120 volts on the contacts, but they are 12 volt DC operation. So the coil side of the relay activates with 12 volts DC. So that'll get it to work, and we'll be able to test it. But as we said before, I have this one controller which only reads centigrade, and the other three that are out on the boiler right now. So we're going to swap that over to the analog controls temporarily, so we can put the digital controllers in here and test this whole mess. We'll probably hook a couple motors up to it and see if these relays blow up or not. If they do, the fallback plan is to temporarily wire in a couple of these solid state relays. The reason we're not using the solid state relays is because these things get tremendously hot, and I would not want to run them inside of this box. So the other option is you could run them, you know, bug some wires out of the box and run them outside the box, but I don't really want to do that. This application doesn't really need a solid state relay. We're not switching the things on and off really fast or anything, so a regular old mechanical relay will do fine if we ever get them in here. So yeah, okay, more when we get it together and we test it. Okay, so we've gone back to our analog controls here. Got the single aquastat controlling the boiler temp, and this part of an aquastat controlling the ashing temperature, which controls the relay, which turns the auger motor on and off. So now we have to finish up our electrical box and test it and see how it's going to work. Okay, we're nearly done wiring up our test setup here. We have put the Inkbird controllers into the front panel. And we've got the hots and grounds, hots and neutrals wired to them, and the K-type thermocouples are attached to them. Now we just need to wire the outputs of them to the relays, which is pretty well done. I have these pigtailed out already. That one's for the auger. This one is for the boiler controller. And this is the main hot, so that gets connected to, it'll get wire netted to these two. And this is the main neutral here. And this is the neutral for the hour meters. So they'll go together and connect it to the main neutral. And we have a jumper that needs to go between these two, so we can run this as the ash inhibit for the stack temperature part of it. Alright, let me finish up this little bit of wiring and we'll fire it up and see what happens. Okay, so we're ready to do a little test here. All the spaghetti is wired up. We have our thermocouples here. This is the stack, this is the ash, and this is the boiler controller. I have this wired to have a fused switch from another boiler that I had, and I just pigtailed into that and ran a regular plug on the end of some Romex into the wall, so when I turn this switch on, it should come on and hopefully not blow up. You can also see I have these two motors. They're in play, so right now I have the switches turned off. Well, let's see what happens. Ooh. Inkbird's booted up. It's a good sign. So the boiler is calling for heat now. For some reason, the ash is way up there. So actually, but we swapped them around, so we'll have to change the settings on these two. But anyway, so if this all works right now, we should be able to flip the fan switch on, and this noisy motor should come on. Let's see, fan, right? Okay. Wow, bearings sure are bad in that thing, aren't they? And to get this guy to come on, let's go into this menu here and change some settings. Don't change anything here, no. Don't need that outrageous offset anymore. I'll have to retune this, so I'll just leave it with a positive offset of 10. go. There's that. EL no. Oops. Operation off. We want this for heat now. Auto. Don't care about the alarm menu, don't care about the PID. There you go. So now these two are both enabled, so this other motor should come on. There we go. So it seems to work, even with these automotive relays. Let's see if our boiler will shut off when it reaches the set point. Oh, sorry, that's the ash. Okay, well, we'll see if that shuts it off. So this should come down pretty quickly. Six, 175. That should turn the ashing motor on once it gets below 170. There we go. Now, that one's the ashing. This one's the boiler. Let's see if we can make that turn off. Go. ASTI motor turned on. Turned off, turned back on again. Man, that is a nasty sounding motor. Okay, so it works. Seems to do everything we need it to do. Now I just got to install it. And when we get the correct relays in, we'll swap these out with them. And everything should be good. Here we go.